Good morning, good afternoon, good evening, everyone. Welcome to our webinar, Releasing Better Games Faster, the Continuous Delivery and the Need for Speed. Our webinar today is in a panel discussion format exploring the approaches taken by some successful gaming companies that are using continuous delivery practices to release their games faster. My name is Gabe Weiss. I'm a technical lead and the unofficial gaming evangelist at Perforce Software, and I'll be moderating today's discussion. With me on the panel today are a few highly experienced engineering and release management professionals from Turbine, Ubisoft, and Sony Computer Entertainment. All three of these companies are Perforce customers. So here's how we're going to do it today. I'll introduce a topic for our panelists and ask that they weigh in on how they're addressing that particular issue. We'll save some time at the end for questions from our audience, so please send in your questions via the Q&A widget. We'll be sending a link to the recording to all the registrants by the end of the week. And something to keep in mind is that the topics we'll discuss today are relevant to really all companies in any industry. We've seen that the game developers are usually leading these other industries in this particular adoption of the continuous delivery practices. And with that, let's get started. I'm very happy to introduce our panelists. I'll start by introducing Nathan Sitkoff. He is an engineering manager for the Lord of the Rings Online, a Tolkien-themed MMORPG developed and operated by Turbine. Nathan's been working in the game development for over 15 years. Nathan, why don't you tell us a little bit more about Turbine?
Hi, this is Nathan Sitkoff. So Turbine used to be a privately held company, but now we're wholly owned by Warner Brothers Home Entertainment. We were acquired in 2010. We're known for such games as Asheron's Call, Dungeons & Dragons Online, The Lord of the Rings Online, and our latest release, Infinite Crisis. As Gabe mentioned, I'm the lead engineer on The Lord of the Rings Online. It's developed right now by a team of more than 20. But the literature development goes all the way back to 2003. And it includes more than 500,000 change lists, which have been made by more than 100 people.
Perfect. Thank you, Nathan. Next, I'd like to introduce Pierre. Pierre Laliberté is a build master at Ubisoft Montreal, where he most recently shipped the Assassin's Black Flag title. Pierre's been working in the gaming industry since 1998, and he's worked on all kinds of projects, from the small independent ones to the giant AAA productions. Pierre, if you would, please share a little bit more about Ubisoft for us.
Hi, this is Pierre Laliberté. Ubisoft is a worldwide producer, publisher, and distributor of interactive games. We have teams in 29 countries, and we distribute games in about 55 countries on the globe. Our largest studio is the one I work in is Ubisoft Montreal, where we have over 2,650 employees, and probably more by the time I'm reading this. 80% of the workforce are currently working in game production. In Montreal, we work on all sorts of games, from the large AAA to the free-to-play to even casual games, and we deliver on multiple platforms at the same time. In my case, I've been working mostly on the Assassin's Creed franchise for the last 3 years, and also on the Far Cry brand before that. Perfect.
Thanks, Pierre. Thanks. And our last panelist is Sean Houghton from the Santa Monica Studios. Sean is the lead tools programmer at SCEA, where he worked on the God of War Ascension. Sean's been working in computer game graphics and game development for over 20 years, and his career as an animator for television and film projects before making the transition to games in 2000. So Sean, if you would, please tell us a little bit more about Santa Monica Studios.
Sure, this is Sean Houghton. And I guess I'm assuming most of the people know about Sony in general, so I guess I'll just talk about the Santa Monica studio. This studio was established in 1999 as part of the Worldwide Studios Group. We make exclusive PlayStation console games, and this studio specifically is responsible for the God of War series. But we also have a team that publishes games from external studios, games like Unfinished Swan and Journey. We have an incubation team system. So internally, we have about 200 people. 100 of those people are on the internal development team, and I work on tools and infrastructure, mostly focusing on the toolpath, build servers, automated testing, that kind of thing.
Perfect. Sean, thanks so much. With that, welcome our panelists. let's get on into the meat of it. So our first topic today is going to be one that applies pretty much universally. People always ask, how do I set up my branches and my integrations? So we're going to jump into that first, branching strategies. Sean, why don't you kick us off? How do you guys do it?
Sure. So a lot of people decide not to use branches. We've tried to adopt branches and try to get all the benefits of them and downplay some of the downsides. But we mostly use a developer branch, mainline, release branch system. So each developer has his own developer branch where he can commit freely, and there's no restrictions on what's going on in there. And then you can request an integration into the mainline, and that goes through some automated testing before it's integrated, which I guess I can talk about in a little bit. And usually daily, maybe every other day, the QA approves a build off the mainline, and we promote it to the release branch. And the studio internally works off the release branch. So that's for the code line. For data, we don't use branching. Generally, everybody works off of a single mainline in the data depot, with the exception of some prototype branching, which happens using task streams, which are meant to be disposable, so they don't go back into the mainline, and that's so we can avoid the problem of no centralized locking when you have lots of different data branches. Let's see. We also use Git. So some of the programmers like using Git locally. So we use Git Fusion. Some people use Git P4, but most of us use Git Fusion just with lots of little tiny branches locally before we actually commit it to the developer branch locally. And it's worked out pretty well. We haven't had too many problems with it. So.
And I just wanted to call you. So you guys are using streams.
Yes.
We
so we're
heard
using.
the word. I just wanted to highlight that you guys are actually using the streams also, which is integral to this whole branching strategy stuff at times.
Yeah, we used to sort of manually manage it, and we've recently switched over to using all streams to manage the branches, and it's made it a lot simpler and a little more formal. So, yeah, we are using streams.
Nice. So next, Nathan, what about you guys? How are you doing it?
Hi, this is Nathan Sitkoff. We maintain 3 branches, our mainline or dev branch. We also have a beta or QA branch and a live branch. The live branch is always reflecting the version of the game which our players are playing. We do periodic full integrations that are done by our engineering team from our dev branch to our QA branch, from our QA branch to our live branch. And then between the integrations, between those full integrations, they occur every, like 3 months or so. We'll do partial manual integrations on a changeless by changeless basis, and the developers are responsible for doing that themselves. This, of course, has a danger because there's always the chance that we might, for example, fix a bug in the QA branch but not make that fix to the dev branch, and then there's the danger that when we do our next full integration from dev to QA, we might reintroduce that bug. We might remove that bug fix. So we have a lot of scripts that we've developed to try to assist with our full integrations and to pick up on any of those QA-only fixes. We also have different changeless note processes that help us with that. Yeah, that's basically the way we do it.
Cool.
This is Sean here. Can I ask a question? So you don't integrate, if you make a fix in a QA branch, you don't integrate it back into the mainline?
We do. So the developers are responsible for doing that. If they make a fix in the QA branch, they're responsible for making that fix in the mainline. But then we have these periodic full integrations where we push everything from the mainline back to the QA branch.
Sure.
So the danger is if they only fix it in the QA branch, then the bug will be reintroduced potentially in our next release.
So the scripts that you're mentioning, are those designed around highlighting, hey, this change hasn't been brought down yet, and notify somebody?
Yes, we have. Well, for example, sometimes we will make changes that we don't want to be brought down. We might be hiding a feature or something like that, and then we'll have changeless notes, let's say like no merge, and then our scripts will know that even though we see that changeless was made to the QA branch but wasn't made to the dev branch, we shouldn't flag it as a problem. But we do have other other issues where we have change lists that are difficult to match up because they're binary files and they can't be merged because they've changed in both branches and need to be individually edited.
Mm-hmm. Makes perfect sense. Sounds good. So, Pierre, how about you weigh in? How do you guys do it?
Hi. Sorry. In our case, we're using mainly a mainline. It's a regular model where all the programmers are committing all the changes. We get a lot of load in there. We can get to up to 200 changes of code per day when we're in peak. What we do is we call it a stabilization branch. Every night we do a full replication of the main line inside the stabilization branch. And throughout the day we will stabilize the build, the editor build, what we call the tool set. We will integrate hotfixes from the main line when it's needed. And then we're going to release a new build every day from the stabilization line. And once, at the end of the day, we're going to replicate that stabilization line inside a live branch, or we call it the production branch. This is mainly if we need to release a very, very fast new package on the production floor, but it's very rare that we use it. Mostly all the work happens in the main line. We allow programmers, of course, to do whatever they want, in the sense that they can have their own playground branches if they want. Some programmers also use Git P4. We don't use Git Fusion yet. For the data, they have their own branch, which we rarely branch it. All the artists and the content developers work inside that branch. That's pretty much it.
Mm-hmm. Alrighty, so that is 3 different branching methodologies. Just to sort of bring it back, Sean, you guys are using streams, but Nathan and Pierre, neither of you guys are using streams yet. So you're managing your branches through branch views mostly?
Yes, mostly.
Okay. Alrighty,
Yeah.
so moving forward, our next topic for you guys is going to be the cross-team collaboration. So this is not just sort of there's 2 different pieces of this that I like to think of as cross-team collaboration. There's cross-team, cross-office, so we have sort of global teams interacting with each other, and then within the same office, we often have, particularly in the games industry, we'll have the programmers working with the artists, working with the designers, and how those teams sort of interoperate as well. That's kind of what I'm looking for. So this time let's start off with Nathan. How do you guys work within your different teams?
Hi, this is Nathan Sitkoff. We have we have a team of game systems engineers. We also have artists and designers and sound designers, and we have core engineers. So we have a lot of different people who are working in our tree. We have one tree which has both our code and data resources built into it. We do have a set of tools that are integrated with Perforce mostly for our artists and designers, and they'll automatically check files out. But our developers are responsible for checking their files in themselves using the P4V client. We have a lot of practices that we try to promote, including use of various tags, homegrown tags that we put in our change list notes, and that are picked up by various processes. So, for example, we'll put a tag in our change list notes for external notes, and those will get picked up by our OCR team, so that when we do our next release, we make sure that we're telling our players about all the new stuff that we're bringing them. And also we have QA notes to help with testing, and as I mentioned before, we have notes that help us know whether change lists should be merged or shouldn't be merged between branches. And we even track what bug numbers are being fixed. We also try to keep our change lists small. That's something we talk about a lot, trying to make small changes, checking in often. It makes merging much easier, and it also helps with peer review if your changes are smaller. We have a rotating developer support engineer role, so every week one of our game systems engineers is our developer support engineer, and they're available to help our designers and artists and sound engineers with any problems they have integrating their changes or with our tool set or anything. Like the other guys mentioned, we have continuous integration to help us pick up on problems during the day. Just to mention a couple of our pain points, the things that are tricky are, binary files, because we check those in, our texture files, things like that, can't be merged well. So that's something that we need to be especially careful with. It's also really important to normalize your tools so that your text files are merge friendly, so your tools aren't rearranging your XML, so you can't merge them correctly.
So you mentioned just one. I wanted to ask a question of my own. You mentioned these tags that are entered to sort of signify different stuff. Are those are they put in by the tools themselves? Or are they sort of policies that have grown that individual users, that your individual like developers have to add themselves? How does that work?
We've baked it into Perforce, so into the Perforce client. So when you create a new change list, the tags appear. It's part of our standard Perforce install. So then you just need to fill them in. Nice.
All right. So moving on with this one. Hey, Sean, how about you weigh in on this one for collaboration a bit?
Sure. So my take on this topic is more, I guess, focused on sort of the how we collaborate with the team through giving them builds and the stability of the builds. And I mentioned before that we have sort of the development branch, which can be pretty unstable, the main line, which is more stable, and the release line, which is supposed to be pretty stable. So that's how we get the builds out to the team and ensure they're stable. One interesting thing that we do that I thought I should mention is the way we deploy applications. So we deploy our builds. People can download builds. They're made from the build server, and they can download them. But we also, every build that somebody gets has a list of which revision of which piece of software they should be getting. And when I say software, I mean external software like Photoshop or Maya or Python or any of that stuff. And every time you activate a build, we actually sync those applications to the revision that is compatible with that build. So the idea is that you can roll out a new version of Maya or a new version of Visual Studio at any point by just checking the new version into Perforce and then updating this file that goes out with each build that says, okay, now you should download this version of the software.
So you guys actually check in your tools as well, the actual executable tools into Perforce also.
Yeah, we have an applications depot that just exists for application deployment, and I thought that was kind of an interesting thing. I'm not sure how many people are doing that. It's kind of painful sometimes because not all tools are relocatable, and sometimes you have to just install it once, and then it can be deployed this way. So if anybody's listening who writes software like this, please make it relocatable because it makes this a lot easier. And when you can do it, it's really nice. We roll out all kinds of patches and updates to software this way, and it is sort of transparent to people on the floor. They just activate the build, and all of a sudden bugs are fixed in all their various applications. So that's kind of I like that approach. It's worked pretty well for us. Let's see.
Sure. I haven't heard of too many companies doing that where they actually directly check in their development tools either.
Yeah, and we keep asking all of the vendors to make their tools relocatable. So that's my mission in life is to get them to do this. Let's see. So and I guess I can talk about a little bit of the automation in the next topic, but that's kind of how we collaborate cross-team. For us, it's
cool.
It's sort of a small team, so it's mostly deals with builds.
So then, Pierre, we might be having some technical questions. Pierre, are you there?
Yep.
There he is. All right. So Pierre, why don't you weigh on this one a little bit too?
I just want to compliment what Nathan said first, and also what Sean said. We do use a lot of those approaches as well. For example, we do put some of the tools binaries inside Perforce when it makes sense, especially if it's not too big. For example, putting part of an SDK or putting the compilers directly inside Perforce makes a lot of sense sometimes, because when you sync the code, you're sure that you have the proper tools to go along. So that makes a lot of sense. It's easy to maintain as well. It's also easy to, in our case, because we're using a lot of what I refer to multi-site studios. For other studios that are around the world, they just need to sync the code, and they're gonna get the same environment that we use in Montreal. So for me, well, I think Nathan and Sean covered a lot of stuff. I'm gonna talk a bit more about multi-site development because in our case, we have cross-team, but they're spread around the world. Most of their recent production, like I worked on, it's about 8 studios or more. So it's a bit challenging, but what we're using is we're using proxies, of course. We're using edge servers now. Anything that can make other studio work faster, because all the servers, the main servers, are located in Montreal. So it makes a lot of sense to use every tool available at our disposal to speed up things. And sometimes it's not just like Proforce tools. Sometimes we just go around and develop our own approaches. For example, there are some commands that were expensive to use, like a huge P4 flush with thousands and thousands of, well, actually millions of lines. What we do, we have a small server in Montreal that will run the commands locally, zip the output, and then send the output back. So instead of taking hours, it's taking minutes. This is no longer useful because the latest API, we can hide the output, but in the past it served us very well.
So you mentioned that you guys are using the edge servers. Did you do any kind of metric as far as looking at what kind of improvements you got out of it? It's new tech for us, and we just put it out in the wild, so anything we can see.
No, we did not do any metrics yet. We're still deploying it. As far as I know, we have 2 studios using it right now. Well, the metrics is the difference is between instant and taking a lot of time. So, I mean, it's much less painful for the users, but we did not do any full metrics yet. This is something that we're going to do before we push the edge servers throughout or other studio that are working with us.
Very cool. Well, I'm curious to know. So if you would let me know when you guys do, I'm curious to see what the results end up being.
Yeah, sure.
So that all ties nicely into our final topic before we get to the questions from the audience is the pipeline acceleration topic. So this is really about the continuous delivery story, which is getting your tools chain, getting everything tightened up as much as possible, ways that you sort of improve the performance of the development teams to get stuff to market faster. That's sort of the meat of what we want to hear about. So to start this off, let's keep going with Pierre. I know you've done a lot with the build system stuff, so why don't you just sort of weigh in and tell us how you guys have tightened up your pipeline.
From our side, one of the issues is we're working on AAA games, so-called AAA games, meaning that's very, very large teams, and it's always getting bigger. 10 years ago, we would do, for example, a Splinter Cell, and we could compile the code, bake the data on a single build machine, and it's going to be fine. Now it's taking a lot of machines just to be able to do that, and also we want to make sure that iteration times are as fast as possible. Because if the users, meaning the content producers, cannot generate the data to see the results, it's going to have an impact on the quality of the game at the end. So what we're doing now is we're doing a lot of optimization, of course, and parallelization. In our case, the build farm has scaled a lot. In the past, it was, like I've said, a few machines. In our case now, it's for my own project, we're about 140 machines, and we can also use a private cloud infrastructure if we need an elastic burst of processing power. So we have architects also working continuously on improving the pipeline efficiency. Okay, well, one of the easiest optimizations we've done in the past is, of course, upgrading the hardware. We did benchmarks and tested various possibilities. So the first thing we did is upgrade, for example, the hard disks using SSDs everywhere. The network attached storage was also a bottleneck, so we had that upgraded as well. Code compilation is something that we are trying to. It's always a fight to compile as fast as we can because we have hundreds of changes of code. So we try to keep this as fast as possible. We generate every changes of code on every day.
Hey Pierre, this is Sean here. Can I ask? So you said you upgraded your network. Are you using 1 gigabit or 10 gigabit?
It's multiple. It depends on the teams, of course. In our case, we're using several lengths of. I don't know the latest numbers. Let's see.
I know this has been an area where we're upgrading our network shortly for very similar reasons. So.
Yeah, I'll have to check on that because I'm not sure about the latest numbers. We did upgrade the network often in the last 3 years because we kept hitting the limits of the network. It's also what forced us to change how we deploy the build and the larger files. It's something I can talk about a bit in a sec. Well, for compilation, one of the things I wanted to say is that we're using SNDBS and Incredible sometimes. We're also starting using FastBuild, which is an open source tool that works on all the platforms that we work with. It's very fast. It also has distributed builds as well. And about the issue you just talked for deployments, well, some of the studios that I've worked with, they had a lower, they had very low performance network attached storage. So what they did instead, they used build machines and then they used torrents internally to transfer the files. It works for them. It's not something that I'm using because we can manage with other more efficient or easier to manage to maintain. But torrents, for example, is a nice touch internally.
Sounds good. So next, let's move on a little bit, and let's, Sean, I know you mentioned earlier that there's a lot of automation stuff, so let's dig into that a little bit.
Sure. So, excuse me. So we have definitely focused on automating as much as possible, and we don't have a huge tools group, so the more we can let the computers do the work, the better. So I know most programmers like automation, so we've been able to focus on that quite a bit. We automate everything from build production, which kind of is what we've been talking about. We also automate testing, packaging, deployment to the team, and we've now started getting on the DevOps bandwagon and automating building of all the servers and everything using Puppet. So lots of automation happening. You know, if the servers can do stuff and you can go home and sleep, then you're in good shape. So that's the goal. We make pretty heavy use of Jenkins, Python, and Ant. Those are sort of our go-to tools for automation. We have a similar sized build farm to Pierre. We're using, I think, around probably 130 VMs, and running on OpenStack shortly. Half of them are on OpenStack now, and more to follow. Let's see. And most of the automation efforts go towards automated testing. So I mentioned earlier that we have developer branches and a main line, and we have broken our automated testing into two pieces. So we have a pre-commit test that has to happen, and then we have post-commit tests that run as fast as they can that take longer, that just let us know if something broke or that something that was recently checked in broke something. So the pre-commit tests are kind of interesting. They're also broken down into two smaller pieces. Code, because we work in developer branches, we can submit integration requests to a server, and that server will integrate the code, compile all the different versions of tools, all the different variants, the PC and PS4 platform. And if everything passes, then we start up a couple really basic smoke tests to make sure you could build a level, launch the level, reset the level, that kind of thing. And if all that passes, then the build server will integrate the code on your behalf. And that takes around between 5 and 15 minutes. So we can handle something like 40 to 60 commits a day. So it works well with our team size. Something like Pierre, I know, would have problems with that, with the volume of commits going in. So on the other hand, we have content, which is not branched. And so we have a different system for that, where we override the commit, the submit options in P4V, and the content team can basically submit test requests, and then their content is zipped up, sent to the build server. We run a whole battery of tests on it, and if it passes, we put a little token in Redis, and then we have a commit trigger that ensures that you have a ticket to submit that change list. So it works pretty well. That only takes about 15 or 20 seconds. So the content team, they were initially a little bit hesitant to have to go through a little bit of extra work to get a commit in, but now they actually asked for more tests. So it worked pretty well.
So a quick question I have for you that it might be not clear to a lot of our audience that aren't games people. You say you have tests that verify that this stuff, but it's a game, right? I mean, how do you verify that something is okay?
Sure.
I don't know if you can speak a little bit to that.
Yeah. So the code side's pretty easy. Basically, we just run a basic smoke test. If the game can start and not crash, then we consider it good. That it's basically the bare bones minimum fastest thing we can do, and it actually catches quite a bit of problems. Mm-hmm. For the content side, it is a little trickier, but the content team writes a lot of stuff in a scripting language, which is compiled, so we can pretty easily check if there are syntax errors. There's a lot of JSON file content that goes in. We make sure that the JSON files are valid JSON. There's lots of little kind of low-hanging fruit tests that we can use to ensure that stuff is not obviously broken. We're not going to do something like, every commit, can you play the game from start to finish without any problem. That's definitely not going to happen as part of a commit test. But there's a lot of low-hanging fruit you can get around. Yeah, and like I said, it takes 15 seconds, and we can cover quite a bit of ground with that. Let's see. So yeah, and a lot of that automated testing is driven with an internal. We use Jenkins as the job runner, but we developed an internal sort of test aggregation and viewing web system that we use to organize that, to display claims, to send out or display failures, to send out notifications, to claim test failures, all of that kind of stuff. And the goal is, which we got to on Ascension, was automating all the way through from checking in a piece of content all the way through to a burned Blu-ray popping out the other end. And initially that took 24 hours, and then like Pierre said, after you start distributing it and organizing it and setting it all up, we got it down to about a half hour where we could build the entire game and produce a Blu-ray at the end. So that was really good to get that done.
Not too shabby. So real quick, if you wanted to, Nathan, I know we've chatted a little bit about your CI setup. Do you want to just weigh in a little bit real quick here?
Yeah, we have CI running during the day, and we have a nightly build process as well. Our CI is we have separate CI for code and data. Actually, our code CI is named Shaminator, and our data CI is named Blaminator. Our code CI runs about an hour behind. Our data CI is more of a challenge. Our data build is really slow. We only get a couple of those off a day, so we're definitely not as advanced, I think, as some of your other panelists are when it comes to advanced and really rapid CI processes.
We just threw a lot of hardware. Sean here. We just threw a lot of hardware at the problem, so I don't know about advanced, but
sometimes you just do what needs to get done.
Yeah.
All right, well, thank you guys. That was a good primer for us to get going, and now what I find the really interesting part is diving into some questions from our audience. We've already got some good ones coming in. So the first question that I've got, this one's actually from us here, is what do you know now that you wish you knew when you started all of this? So first, let's go to Sean. Sean, what do you think?
Okay, let's see. So I think this might fall into the category of stuff I probably knew but just didn't think about, and that's usually automation and sort of toolpath stuff and build production starts off as a bunch of hacky scripts that you kind of whip together and kind of disparate systems that you connect with hacky plumbing. And then eventually your entire studio depends on it, and now you're left with sort of a hacked together system. So we've spent a lot of time going back and really making everything robust and reliable. So I wish that I had started knowing that we would have ended up with such a not elaborate system, but a sort of a real complex and system that needs to be reliable from the beginning, and then we would have engineered it. We wouldn't have had to keep iterating on it so much. But
maybe have some process around getting them in, that kind of thing.
Yeah, it's easy to start with hacky scripts because you don't think you're going to need anything more.
Sure. And what about you, Nathan?
So I guess I wish that I'd realized that artists and designers aren't engineers. I think that I kind of didn't appreciate the scope of that difference. And there's a lot of assumptions that engineers make about the ease of integrating their work and the importance of stability versus the importance of speed. And those just aren't really the same trade-offs that the artists and designers want to make. And I've spent about 7 years now trying to get the designers and artists to think and want to work the way that I do, and I kind of realize that's not going to happen. So, starting to develop some better processes that are better suited to their better compromises that are better suited to the way that they need to work. One big thing is that is to just build fragility. We have our own system for. As part of our data compilation process, we have our own data verification, kind of like the tests that one of your other panelists was talking about. I forget whether it was Sean or Pierre. But what we do, like how we report errors and what we do to the build, we used to just stop the build, whenever we had any error. And now more and more we just, we try to just report it and keep going. We do whatever we can to keep the build alive. But the trade-off there is, there's always a danger that you're going to ship a problem,
Mm-hmm.
So as an engineer, I think you want to be like, it's either broken or it's not broken, like black or white, But it's really not quite that simple.
If only it was that easy. So another question coming in, we have a question of, how do you guys deal with outsourced teams to avoid merge issues, specifically with repositories that are maintained with two different version control systems? Do any of you guys have a system like that set up where you're taking code drops from external contractors?
This is Pierre. In our case, we're always using the same source control. Trying to use a different source control is asking a bit for trouble. But ways I could see of solving this is try to use some sort of pre-commit tool that you could use on both SCMs, for example, and then you could try to resolve and see if the file has been modified on one SCM and the other one. So you could try to emulate the fact that you use the same, but you're not using the same. For example, you're using Perforce on one side and you're using Subversion on the other side. The tool that you're using to do the pre-commit could try to figure out as the file changed on the other side, and if so, then perhaps you need to pull that file back before you can do the change in your code line.
Sounds like, this sort of problem sounds kind of similar to just working with other offices. It's a similar sort of problem set.
Yeah, Sean here. So we have that problem. We do a lot of collaboration with internal Sony groups that use all kinds of different revision control systems and that we can't connect. And we usually just use the sort of simple brute force approach of delete. We keep a repo of the original source code, and every time we get a new drop, we just delete it, drop the new code in, reconcile offline changes, and submit it. And then we integrate it into a location that has our local changes, and that way we can do merges and sort of keep our local changes alive. It's a little tricky.
So the next question I've got coming in, did any of you guys encounter resistance when you first switched your branching strategy? And if you did, how did you guys overcome that resistance?
Sean here. So we don't have a lot of resistance with development branches. The main source of resistance we have is we don't allow the integration server to auto merge files. So you have to, if there's a merge conflict when you try to submit an integration request, it'll just boot your request out, and you have to pull from main, do the resolution locally, and then recommit. So it's the merge down, copy up thing that we do. That one's been a little tricky because some people just want to, have a checkbox that says, if you think you can do it, do it. But we're try to be a little more anal retentive about it. So that's maybe the only source of conflict we've had.
Nathan here. We actually did have before we moved to the model that we're using now for branching, which was like a dev, which is our promotional model where we do these full integrates between three more or less static branches. We were using another model where we were creating new branches for every release. But that wasn't really serving our needs so great. Comes back to my artist designers question. They didn't. A lot of the less technical people on our team didn't want to maintain and have to keep replacing all these branches. So this model was a lot more friendly. The one that we're using now is a lot more friendly for most of our developers. But our sort of Perforce administration team didn't want to maintain it. That is, they didn't want to be doing these integrations. So we took so the way we solved that is we took responsibility for doing them onto ourselves. And then we developed our own tools to handle it.
So this next one, Sean, you began to touch on this. Do any of the panel companies have issues with non-engineers using Perforce? Does anyone have sort of Perforce helpers to check out and submit files, or have you had specific trainings that helped with that? Basically, I think the question is, how do we get artists working with Perforce?
Yeah, so it sounds like Pierre has a system where they do a lot, and maybe even Nathan actually, where they have their own interface to Perforce or sort of do things automatically. We have a lot of basic integration stuff where the files just get checked out, and then they use P4V to manage the change lists and everything. And yeah, we have, we have a fairly complicated setup, and especially now that we've started using prototype streams where the artists need to actually sort of understand about branching and when they can integrate back into main and when they can't, and how global locking works, and that kind of stuff occasionally comes up. And we have 3 or 4 people on the team who are sort of dedicated to Perforce support, and the tech artists are a little bit more advanced than the rest of the team, and they can help people. Is that what you're looking?
These were the floaters that you talked about earlier. That's the support guys.
Yeah.
Great. Well, we've got time for one last question, and the question is, if you can you guys share your reference architecture on how you created the continuous deployment pipeline using the different tools that you've mentioned? So how did you come up with the architecture that you've got, basically?
Speaking for myself, this is Nathan. It's definitely been an evolution over time, and it continues to evolve.
So it wasn't one set that you saw out there and said, this works for us, let's use that one.
Not for us, it wasn't.
Okay.
It was not.
Yeah, I agree. It's definitely been, you fix the weakest link, and now all of a sudden a new weakest link shows up, or the team changes direction, or the project changes phase, because early on in a project you have very different requirements for deploying to the team and automated testing than you do when you're in the ramp up 3 months to ship, when you want to keep everything stable, you want everything to be super fast, versus early on when you can change everything. So we've probably had 5 epochs of, or whatever you want to call it, of different architectures of the build system.
Well, perfect. Thank you, guys. A huge thank you to our panelists for joining us. It's been a lot of fun. A link to this recording will be available at the end of the week. We'll go ahead and send a link out to that to all of the attendees. There were a lot of good questions. We obviously didn't get to all of them, but we will follow up, and if there's questions for the panelists, we'll follow up with them. Otherwise, we'll try and get back to everyone and answer all the questions that we didn't get to here. Again, my name is Gabe Weiss from Perforce. If you wanted to follow up specifically that we didn't get to, please feel free to email me, and I'll follow up with you directly. And for our next development talk coming up, we've got code review workflows with Jeff Nickel coming up. So please come back and tune in. Thanks everyone for joining us. This is Gabe Weiss from Perforce Software.